and welcome. Dear friends, this video is in continuation with our first video related to introduction of structural dynamics and earthquake engineering. I am Dr. N.S. Naik from the Department of Structural Engineering, Sanjani College of Engineering, Kopargaon. Now, this is about unit number 1 of the syllabus. This unit number 1, it deals with definitions. So, different definitions we will be discussing under this unit. Then introduction to seismic hazards, earthquake phenomenon means what is earthquake and so on, seismic zones of India, what is mean by earthquake size, the concept of isoseismic maps, what is mean by earthquake magnitude, and the phenomenon of tsunami. So let us start with the different terms related to earthquake engineering or earthquake. So what is earthquake? So earthquake is nothing but a wave-like motion of earth's surface, or it is a temporary burst of energy which causes a random oscillatory movement. It is a wave-like motion. This is a general definition which we are using in practice. It is a wave-like motion of earth's surface. So wave-like motion like this, or it is a temporary burst of energy which causes a random oscillatory movements. So when huge amount of strain energy is stored in earth, interior of earth, suddenly it bursts, and the burst of energy, strain energy more precisely, is called as earthquake. So here uh, earthquake is a wave like motion. Okay, so here I will show you one animation of one of the waves of earthquake. So here the movement of earth surface is wave like. So this is earth surface, and the movement of this earth surface is taking place similar to a wave of water. So this wave like motion is called as earthquake. Now interior of earth. So here this is the figure which shows section of interior of earth. Interior of earth, it consists of three layers. First one is the crust, which is on the earth surface, then mantle, and then core. So this is core, and this core is further divided into two parts, inner core and the outer core. And surrounding this outer core there is a mantle, and above this mantle there is a crust. So let us see what is core. It is the central region of earth composed mostly of iron. So this is the central region of earth. It consists of mainly iron. There are two portions of the core. Number one, inner solid core, which is under great pressure and has a radius of about 1250 kilometers. So this is the inner solid core. This is the inner solid core of earth, and this portion is under the tremendous pressure, and it is obvious it is far below the surface of the earth, and hence a tremendous pressure is acting on this portion of earth. Its radius is about 1250 kilometers. Now second part is outer molten core. So this is the molten core, this is the solid core, this is the molten core, and this complete section is called as core. This molten core is having a thickness of about 2200 kilometers. Then the mantle. The core is surrounded by another layer called as mantle. So this is mantle. This mantle is surrounding the core, which is about 2900 kilometer thick and contains most of Earth's mass. It is solid, but it can deform in plastic manner. it is solid but it can deform in plastic manner. This is important, and this property is mainly responsible for earthquake. Then the crust. The mantle is surrounded by a relatively thin layer. So this is crust. It has a thickness of about 35 to 60 kilometers under continents and 6 to 10 kilometers under oceans. This layer is brittle and susceptible to fracture and susceptible to fracture. So this crust and this mantle which can deform similar to a plastic material, these two layers are mainly responsible for earthquake. Thus these are the three layers of Earth's interior: the core, the mantle and the crust. Okay. Then sources of earthquake. So what are the different sources of earthquake? There may be a question like this: what are the different sources of earthquake or seismic sources? So the earthquake or the seismic sources can be classified as natural and man-made sources. So there are two types of sources: natural sources and man-made sources. So natural sources are tectonic earthquakes. Tectonic earthquakes are mainly take place mainly because of movement of plates or earth surface. Then the second one is volcanic earthquake. Volcanic earthquakes take place because of eruption of volcano. And third one is rock falls or collapse of cavities. So when there is a rock falling or when there is a collapse of cavities in the interior of the earth, it results in disturbance in the equilibrium of interior of the earth, and thus it results in earthquake. So natural sources may be tectonic movement of plates, the volcanic eruptions and rock falls or collapse of cavities. While the man-made sources are three. First one is explosives. When we are using explosives, it results in earthquake. Then reservoirs. Reservoirs are constructed to store water on their upstream side, and this tremendous weight of water which is acting over the crust of the earth results in earthquake or may trigger the earthquake. Okay, the well-known example is Koina earthquake. Then third source is mining. When mining is taking place at greater depth, it results in earthquake or it may trigger the earthquake or the movement of rocks within the interior of the earth. So there are different theories suggested by different notable scientists and researchers about earthquake. One of them is theory of plate tectonics, or simply called as plate tectonics. So here this is the figure, or one can consider this figure both are the same. This figure shows a section before the tectonic movement, and this is the section after the tectonic movement. Okay, so here this is continent, earth surface, and to this side this is ocean. Below the earth surface and below the ocean there is a layer of crust called as continental crust, and this continental crust is having more thickness below the earth surface, below the continent, and a nominal thickness or less thickness below the ocean. So this is called as oceanic crust. This is entire layer is crust. This is below the ocean, hence called as oceanic crust. It is having less thickness. This is continental crust since it is under the continent. And this continental crust, below this continental crust there is a layer called as lithosphere. There is a layer called as lithosphere. So this lithosphere is there under the continental crust and under the oceanic crust. Below this lithosphere, there is a plastic layer called as asthenosphere. So this layer is a plastic layer. This layer is plastic layer. Over this plastic layer, the plates can slide. Okay, so this section is just before the tectonic movement and this is after the tectonic movements. So now I have explained you about these different layers: crust, lithosphere, asthenosphere. The crust below the ocean is called as oceanic crust and the crust below the continent is called as continental crust. So let us see the theory. The crust and the uppermost mantle to a depth of about 70 to 100 kilometers under deep ocean basins and 100 to 150 kilometers under continents is rigid. So this portion is rigid, which is below the ocean and which is below the continents. Now the depth of the layer below the ocean is 70 to 100 kilometers and that below the continent is 100 to 150 kilometer. Okay, and this layer is rigid. It forms a hard outer shell called as lithosphere. Now this is total crust and it consists of lithosphere. This is continental crust, oceanic crust, okay, and this is lithosphere. It forms a hard outer shell called as lithosphere. This lithosphere is called as continent. These continents are brittle and fragmented into several large land masses called as plates fitting together. So this layer is brittle, this total layer is brittle and it is fragmented into several large masses called as plates. For example, our Indian Ocean, Indian subcontinent is a plate. So this particular area is called as Indian plate, while Tibetan plate is there, on which portion of China is there. So that is Tibetan plate or Eurasian plate. So these plates are connected to each other through some fitting. Okay, that we will discuss later on. So thus the entire earth surface is divided into different plates, okay, fitting together. These plates are not fixed in position and they are slowly moving. The Indian plate is moving while the Eurasian plate is also moving. Okay. According to the plate tectonic theory, the lithosphere, which is partly over land and partly under land and partly under ocean, is broken into pieces of oceanic and continental plates that slide over a plastic layer of mantle known as asthenosphere. So here this is the layer of crust, continental crust and lithosphere, oceanic crust and lithosphere. Okay. So what happens at the boundary of ocean and continent? A trench is formed. A trench is formed and at the boundary of this trench fracture takes place to the crust and this fracture divides the entire crust into plate. This is oceanic plate now and this is the continental plate. Okay. The common cause of earthquake is tectonic movements. When oceanic crust converges with continental crust, the denser oceanic plate plunges beneath the continental plate. So here at this interface trenches are formed and here at the boundary the oceanic crust and the continental crust are uh, we can say are fitted together. So it forms two different plates, oceanic plates and volcanic plates locked at this interface. And if there is a break between these two plates, then the oceanic plate it plunges down below the continental plate. So here the plate is moving under or beneath the continental crust. Okay, and this continental movement of continental plate is called as subduction. Subduction, it occurs at the oceanic trenches. So at this interface it occurs, and the entire region is known as subduction zone. And this movement of plates, it results in earthquake. It results in earthquake. When there is a subduction of the oceanic plate below the continental plate, it pushes the magma in upward direction and volcanic eruptions takes place here. So thus mountains are formed at the interface of oceanic plate and the continental plates, and this is volcanic arc. This is volcanic arc. Subduction zone have a lot of intense earthquake and volcanic eruptions. So this is subduction zone after uh, subduction of the oceanic crust below the continental crust. The subducting plate causes melting in the mantle and the magma rises and erupts, creating volcanoes. So here the magma, molten magma, it moves in upward direction and it erupts. So eruption takes place, volcanic eruption. These coastal volcanic mountains are found in a line above the subducting plate. So here these are the volcanic mountains. The volcanoes are known as continental arc. Now here we are having three different figures. Figure A, at the trench lining the western margin of South America. So this is South American plate. South American plate. The Nazca plate. This is the Nazca plate. This plate is subducting beneath the South American plate, resulting in the formation of Andes mountains. So here this brown and red color, it shows Andes mountains. So this is figure B. Convergence has pushed up limestone in the Andes mountains where volcanoes are common. Even in our case, Himalaya is an example of this type of mountain. Okay, so these are the different terminologies or the theory or the terms related to earthquake. Now in the next lecture we will discuss again one more hypothesis, that is gravity loading hypothesis, and we will discuss about the movement of Indian plate and the Eurasian plate, as well as the elastic rebound theory, and uh, so on. So this is all about the different terms related to earthquake engineering. Thank you.